Okay, so in our last set of problems, you were working with rational equations that would turn into linear equations after fraction busting. So now I want to show you an example where your rational equation would turn into a quadratic equation after fraction busting. So I want to begin with the process of fraction busting, which is to take a moment to sort of figure out what our lowest common denominator would be. Here I see a denominator of x minus 2. In the second fraction, I see a denominator of x minus 4. And then in my third fraction, I see a denominator that I still need to factor. I don't know what the factors of it are yet, but I will take a look at how I could break it down. So I noticed that if I multiply 2 and 4 together, that'll get 8. And if I make them both negative, negative 2 times negative 4, I still get the positive 8. But then these terms would be negative. I'd have a negative 2x here and then a negative 4x there. And when I add those together, I would have negative 6. So that kind of works there. So I can see that this third denominator would factor into x minus 4 and x minus 2. So because of that, it looks like all of these factors, like x minus 2 is a common factor, x minus 4 is a common factor between these denominators. So my LCD basically is, there's only common factors in the LCD. So the LCD is just going to be x minus 2 times x minus 4. So now what I'm going to do is I'm going to take my original expression, and then I'm going to take my LCD and multiply it to both sides of my original equation. And I'm going to put my LCD over 1 so that I can understand that these factors are going to the numerator only. So I will do the same thing on this side. Also, I think I might, for this denominator, I might remember that it consists of the factors of x minus 2 and x minus 4. That'll help me when I'm simplifying later. Okay, so then on the left side of this equation, I would need to distribute this LCD to both terms so that I would end up with this. Okay, so now I notice that in the first fraction, I can divide out an x minus 2, and I would be left with x minus 4 times x. In the middle fraction, oh sorry, this is x minus 4, sorry, typo there. But in the middle fraction, my x minus 4s cancel out, and I'm left with x minus 2 times 1. And then in my third fraction, every factor in the denominator cancels out, so I'm just left with 2 times 1. Because when you divide things out, they divide to equal 1. So then my equation would turn into, here I would have x minus 4 times x, and then in the middle I would have just x minus 2 because it's times 1, and then on the right hand side it would just equal 2. So here I have to distribute my x to the x minus 4, and so that would turn into x squared minus 4x. And so I want you to notice right here, I want you to kind of pause for a moment and notice that after distributing my x to my x minus 4, I ended up with an x squared. So as soon as you end up with an x squared in your equation, it's a game changer. You have to kind of stop and recognize that this is telling me that this equation is now quadratic. So we learned how to solve this type of equation back in, I believe it was Unit 2 of last semester. And we learned 3 methods. It was either factoring, completing the square, or quadratic formula. But in 2 of those 3 options, basically factoring and quadratic formula, which are the 2 options we use the most, you need to get a 0 on one side. See, that was not the case with the first example because we were solving a linear equation, so we were just trying to get the variable by itself. But in this example, because I have an x squared, I have to kind of change course. It's a game changer. Now what I want to do is I want to get a 0 on one side. So what I'm going to do here, first I'm going to combine these like terms, my negative 4x, or my negative 4x and my x is 1x. So then I have x squared minus 3x minus 2 equals 2. And then on this side, I want to turn it to 0, so I'm going to subtract 2. That would give me 0 on that side. And then on this side, I would, since these are both negative, you add them up to negative 4. And then these terms just stay the same since they didn't have like terms. So now I'm solving a quadratic equation set equal to 0, and I'm thinking that this one will be able to factor. So I'm going to factor that. Of course, you use whatever factoring method works best for you. I'm going to just stick with the box for me. So I notice if I use 4 and 1, and I notice if I make the 4 negative and the 1 positive, then in this box I'd have negative 4, and in the box down here I'd have 1x. And so if I added them together, that would give me the negative 3x. That's there. So that tells me that x plus 1 and x minus 4 are the factors of this quadratic expression. And if it's equaling 0, then I could solve that by setting each of these factors equal to 0. So I end up getting two answers. One of them is where x is negative 1, and then the other one is where x is 4. And then all I want to do is go back to the very beginning of this question, because remember, we were dividing earlier by x minus 2 and x minus 4. And so I'm not allowed to do that. I'm not allowed to multiply by these and cancel these denominators out if it's a 0 over 0. So remember, 0 divided by 0 is the one value that divided by itself does not equal 1. So because of that, I can't let x minus 2 equal 0, and I can't let x minus 4 equal 0, which means I can't let x be 2, and I can't let x be 4. So when I'm done solving this, I realize 4 is what we call an extraneous solution. That means that it was a solution to the quadratic equation that I changed my rational equation into, but it's not an actual solution for my rational equation because it was a restricted value for my rational equation. So restricted solution for the rational equation. That was the one at the very beginning that had x's in the denominator. I can't let those denominators be 0, so I can't let x be 4. And even though it's a solution to this quadratic equation, it's what we call an extraneous solution, so it's not one of our actual solutions. This one here, this solution would make both of the equations true, both the quadratic equation that I turned my equation into and the original equation up here where I was dividing by the x minus 2's and x minus 4's. So this one turned out to have only one actual solution, and that was negative 1. So just be careful when you do end up getting more than one solution, or actually even if you only end up with one solution, you're going to want to check that with your restricted values and just make sure that you restrict those values from your solutions. Okay, now you guys try some in quizzes.